Good morning, students. Today we will discuss about applications of Bohr's theory. So, what are the applications? Especially this is important for NEET or especially NEET and advanced topic or lecture. This is so one more topic. We already discussed about the Bohr's theory and energy and radius and everything. We already discussed before. But we today will discuss about applications. Applications means in this topic. We are discussing number of revolutions and energies and energy. What are the extra question? Extra topic is any there? We will discuss about. First topic is energy. Regarding energy, electron energy we already calculated and derivation is already taken. That is minus 13.6 electron volts by n square electron volts. But in X that value is energy value is minus 2.179 into 10 power minus 11 by n square into z square x in x. Sometimes just you have to calculate sometimes they ask in x units. Then you confirm that x in that. So I have to substitute this value you can substitute. After that, second formula is there regarding En. Energy of nth orbit, En equal to minus E1 by n square. Here En equal to energy of nth orbit, and E1 equal to energy of first orbit, and n is the number of principal quantum number. So where we are taking, for example, energy of third orbit means we are substituting E3 here minus first orbit energy here, and here 3 square we can substitute. For this is like that. And hydrogen like species. For hydrogen the value is 1 because the atomic number of hydrogen is 1. Therefore, for hydrogen, this is the formula. For hydrogen-like species, you can confirm that is how to write the Z value. So for hydrogen-like species, Z value is not 1. For hydrogen, Z value equal to 1. And for helium, Z value equal to 2. For lithium, Z value equal to 3. Therefore, that will change. Therefore, En of energy of nth orbit equal to minus E1 by n square into z square. Z square you know that is the atomic number. After that, this is third formula of energy. After that, one more thing is there. We know already discussed about total energy, potential energy, and kinetic energy. So we already discussed about the derivation also. Energy of electron derivation is to express from these relations only. According to this, total energy equal to potential energy plus kinetic energy. We know the relation, that is total energy equal to potential energy and kinetic energy. So this is also total energy equal to potential energy plus kinetic energy. So this is lecture 12 of first year atomic structure. So here, potential energy is K is T equal to minus 2 is to 1 is to minus 1. This is the relation P K is to T. So after that, this is about energy. So this is about energies. After that, one more relation is there, that is Rydberg constant. So Rydberg constant. After that, so this is about energy relation. I will run this one. Energy relation is finished. After that, Rydberg equation. So what is the use of Rydberg equation? We already discussed that about Rydberg equation. Nu bar equal to 1 by lambda r into 1 by n1 square minus 1 by n2 square. So this is 1 by n1 square minus 1 by n2 square. So here nu bar equal to 1 by n. For this r is called as Rydberg constant. R is called as Rydberg's constant. Rydberg constant. So that is R equal to 2 pi square mz square e power 4 h cube c. So all we substituted, we get the value. All we substitute electron charge, mass, pi value, 2 value, h value, and c value, velocity of light. That is also substituted. Then we get the value 109,677 into z square centimeter inverse. That is R value equal to 109,677.8 actually into z square. So this is our. For Rydberg constant is also for different conditions are there. Delta E we know that one. According to Bohr's theory, delta equal to E2 minus E1 that equal to h nu. Therefore delta equal to RHC into 1 by n1 square minus 1 by n2 square. Delta equal to h nu. Delta equal to E2 minus E1 by h. That means nu equal to c by lambda. Therefore hc by lambda. So nu equal to delta E by nu equal to E2 minus E1 by that is relation E2 minus E1 by h nu h delta equal to h nu or nu equal to delta E by h E2 minus E1 by h. This is also about Rydberg constant. After that, one more relation is there regarding not only energy differences. Delta E equal to z square RHC into 1 by n1 square minus 1 by n2 square. This is called Bohr's frequency rule. The rule is called as Bohr's frequency rule. What is the Bohr's frequency rule? Delta equal to z square into RHC into 1 by n1 square minus 1 by n2 square. N1 is the energy of lower orbit, lower orbit. N2 is the higher orbit. So after that, this is about energy differences and Bohr's frequency rule. After that, so up to here we have finished. After that, we confirm that velocity. Remove the revolving electron has electron due to Bohr's theory. We confirm that is revolving electron has velocity. So like this, it is revolving like this. Velocity. How can you calculate the velocity? Velocity of revolving electron. So here, velocity of electron is calculated and derived by so many equations. So first here, V equal to 2 pi Z square by NH equal to 2.188 into 10 power 8 by n centimeter per second. For hydrogen, Vn equal to velocity in the nth orbit equal to V1 by n. For hydrogen species, Vn equal to Z into V1 by n. So Vn is the velocity in nth orbit, V1 is the velocity in the first orbit, Z equal to atomic number and n equal to number of orbit. So this is about one of the formula to calculate the velocity of electron. After that, number of revolutions, that is also called as orbital frequency. So orbital frequency is calculated by the formula velocity by circumference. So orbital frequency or right here number of revolutions. So number of revolutions equal to, this is also called as orbital frequency. Velocity by circumference. 2 pi r is called as circumference. Therefore, V by 2 pi r. That after substituting the value 6.66 into 10 power 15 z square by n cube. This is z square by n cube. These are the number of revolution. So time period of revolutions. So here time period of revolutions means Tn equal to 2 by r by Vn. So velocity nth orbit, that is called time period of revolution. Time period of revolution here equal to circumference by velocity in the nth orbit is the time period of revolution. So this is about time period of revolution. One more formula is there. 1.5 into 10 power minus 16 n cube by z square for time period. One more formula, that is after that velocity, this is all is over. After that ionization potential. So ionization potential means the minimum energy required to remove an electron from the outermost orbit is called ionization potential. Here for hydrogen, IP equal to E1 by n square. E1 is the energy of first orbit. Hydrogen species E1 into z square by n square. E1 is the energy of first orbit, z square by n square. En, this is En, it is formula. That is IP equal to 13.6 into z square by n square electron volts. We can substitute, we can find the ionization potential of any hydrogen-like species. So this is about applications of Bohr theory. So after that, one problem. Calculate the velocity of electron in third orbit, and also calculate number of revolutions around the nucleus. This is the topic, around the nucleus. So first you can find the radius. So radius, how can you find? Minus 13.6, 0.5, 3 square into minus 13.6 by, so 0.529 into n square, that is for energy, and 0.529 into n square. So 0.529 into n square radius form into 10 power minus 8 centimeter. First to calculate this value. So here n value equal to 3. Therefore 0.529 into 9, 3 square into 10 power minus 8. So minus 8 here, centimeter, angstroms. I will convert it into angstroms. This is 1 angstrom. So after that, this will be get some 4.761 into 10 power minus 8 centimeter per second. So this is the radius of third orbit. But calculate the velocity in the third orbit. After that, velocity. Therefore, MPR equal to NH by 2 pi. R already calculated. Therefore, V equal to NH by 2 pi mr. 2 pi mr. Therefore, by substituting all these values, V in third orbit, NH by 2 pi. N is the 3 value, H is 6.625, 2 pi, and M mass of electron 9.1 into 10 power minus 28. R value is calculated. By substituting all these values, we get the velocity in third orbit. Velocity in third orbit, we get how much? 0.729 into 10 power 8 centimeter per second. We get this value, velocity we calculated. So after that, time of number of revolutions per second equal to 2 pi r by v. So total number of revolutions that equal to 1 by 2 by r by v, that is v by 2 by r. So v value are already calculated, 2 value, pi value, r value. We know the third orbit. By substituting, we get total number of revolutions. So this is the method to calculate number of revolutions. So after that, time taken for one revolution here. Time taken for one revolution. One revolution here. Simply we are taking like that revolution, and time taken for total. So time taken for the number of revolutions per second, or number of revolutions per second. Total number of revolutions per second. 1 by 2 pi r by v. So time taken for one revolution is 2 pi r by v. So number of revolutions per second is 1 by 2 pi r by v, v by 2 pi r. By the way, substituting velocity, we know that one. Velocity here, r value is already calculated here. Therefore, we can substitute it. We get this value here, number of revolutions per second. So this one type of problems we can calculate. This value, after substituting all this value, we get 2.4 into 10 power 14. How that much of revolutions can electron do in the third orbit? That much, this much revolutions electron get done in the third orbit. So this is about applications of Bohr's theory. Okay. And so checking third orbit, first you find the third orbit radius. After that, find the velocity in the third orbit. After the time taken for one revolution, 2 pi r by v, number of revolutions per second, v by 2 pi, reverse formula. This by substituting all, just you have to calculate radius and only velocity, you can find all the values. Remaining all are constant values. Okay.